In this tutorial we will show some advanced features of SpiderControl. We'll show a couple of macro functions working with vector graphics and creating dialogs. So we will show how to modify the properties of vector graphics like used here. We will show about indexed addressing, which allows us for accessing linear arrays by a control which is scrollable. And we'll also have a look on creating macro functions that will instance structures, and we can reuse these macros by just modifying, by just changing the structure name. And we'll also show how to implement such property dialogs. So one dialog is able to access several instances of the same class, of the same type. Okay, so we will begin with showing how the properties of a vector graphic can be modified. If you look at this button here, for instance, this button consists of several vector graphics which will create this look. So we first have this orange background. This is called button gloss util number 4. We have an arrow on it, this white arrow. There is 2 more skins for the pressed state right here, and another skin for the disable state, which they're all defined by a vector graphic. If you would like to modify, for instance, this orange background button, we can access the respective vector graphic file and the properties. So the properties of this orange background is defined here. We have some values to define the gradient, and we can now just go through it and begin modifying the different values of this gradient. There is more properties that we can modify. For instance, SpiderControl fully supports alpha blending, so we're able to create half-transparent objects, which allows for a very state-of-the-art, very good-looking HMI. So if we modify, for instance, the opacity to 60%, then we will see that the object, if we put it over another object, it will appear as half transparent. Furthermore, we can modify things like the outline strength of this object, and for instance, for this arrow, there is also the possibility to rotate the direction of this graphic, and this allows us to create very easily, very efficient, good-looking user interfaces. So the next thing we want to have a look at is the table control and indexed addressing. Indexed addressing is a way to use internal container variables to modify the scope of a client at runtime. So if we look at the macro, we'll import this table control macro, which does this. So this is the table control that we saw before in simulation. If we look at the construction of this object, we can simply ungroup it, and we see that each element in here is, so this is a standard edit field object, and the secret behind this is the addressing. So the type is a PPO. It will directly display a process point from the PLC. And what it does here, it says, okay, the name of this array is like that, and we will use this dynamic offset, which comes from a container variable. So the container variable is called list_of. This list_of container variable is modified by these buttons, which increments an offset by 1 to increase a line, or by 10 to go up 1 page. And it is used inside this expression by this operator. The operator is called @conf for container offset underline, and it's ended by this character. In front of this expression, we have the base offset of this line. So it's the base offset for the first line. The second line will have a base offset of 2, the third of 3, etc. So the list_of container variable will define the line number of the base of the macro, and we're able to increment and decrement. In order to modify such a control, one column, it is the easiest way to select the complete column, to go to crossref. So crossref will now show us all existing references to PPOs and other reference. We would like to change the reference to this is what's called myArray2 to an existing structure name, and the fastest way is to do the substring replace. So we will exchange the expression myArray2 brackets by something which could exist on a Beckhoff PLC, PLC1, let's say myArray2 bracket. If this array, for instance, would reference a structure, which could also add an expression at the end, so you will just make a substring replace on the closing bracket to some other extension, and we're set. So this is the way how this table control can be easily modified. If we want to change the size of one column, we just select all, move it, we can copy paste, add one column. So like this, working with this control is really very easy, and when we're done, we just regroup it again and it's ready. So what else can we do with indexed addressing? Indexed addressing is in fact a very powerful feature, and I would like to show in the next example how to use it to make macro functions which can be easily attached to a structure. Let's imagine we have several instances of a structure for a valve. So this structure might contain IDs like this. So there is an error ID, there is a mode, there is a power indication, and a bool to switch to manual mode. And we'll now create instances which are called valve 1, valve 2, valve anything. We would like to reuse the same macro function for every instance, and we would like to have a dialog, a pop-up window, which will point to the instance of such a macro. So to do so, I'll just show how this macro here is constructed. So we begin with finding a suitable graphic element. So we have a library for HVAC objects. This library can be accessed by choosing this star icon, and it can be found inside this styles folder in this HLK symbol subfolder, and we will, for instance, choose such an image. So as these are vector graphics, these vector graphics have properties again, and we can modify the properties to show several states of such an object, and depending on the value of this mode, it will show different states. So let's say this is the state for the mode 0 for off. Everything is in gray, nothing is running. We will attach this to a hide condition. So we say this object will be shown as long as the value is 0, or it will be hidden when process point name PLC1.valve1.mode is 0. We just copy this object. Now we want to have an object which is active if the mode is 1. So we modify the condition. We go to repaints or to the vector graphic respectively. So this view here allows us to create a new file of this vector graphic, to have another SVG file with a different name and some different properties. So we will just say, okay, save this as a new file, and it will be called mode 1. So this object has now automatically changed also the reference to mode 1, and we can go into this vector graphic and set some of the parts of this vector graphic to different colors to show the state that we actually would like to have here. So like this we can easily show the same object with two different states just by copying an existing one and add some hide conditions. Next thing we would have done is I've added a drop-down list. So the drop-down list is referencing this valve 1 mode. So here I can select the different modes. The object has here the list of the different states. So we have added mode off, mode 1, mode 2. There is another object that I have used which shows an error. So the idea is this member of the struct called error ID is contains an integer, which is just an error number, and from this error number we would like to create an error text, which is a language dependent. So the reference that we need here is also some kind of indexed addressing. We'll call it error, and then this operator at PPO underscore, then comes the PPO name, which is PLC1 valve1 dot error ID, and end it with the add character again. So this will cause that number, which is found at runtime on this PPO called error1, will be added to the text in the front, which is error. So the error ID will be error 0, error 1, error something. This tag will be looked after in the language dependent CSV, and in the CSV file we will then be able to translate the error codes to the respective text that we want to have. So here I have the examples: error 0 for short circuit, error 1 overheat, error 2 cable broken, etc. The next thing we do is we'll add a simple edit field to display the power of this struct. So the reference goes PLC1 value 1 power, and now we will add functionality to open a pop-up dialog. The idea is that we have one dialog which can, for instance, be added to the foreground view. The foreground view is the view which is always active on any view that you use. You can configure this when double-clicking on the background somewhere, and you see that each of these text views has the property of using a background view or using a foreground view, if you like. You can also leave that blank. So with the very same foreground, we're able to reuse the same functionality again and again. So in this foreground, I have designed a dialog, a pop-up window, which references our structure. The structure is not referenced directly, but with indirect addressing using the CO for only container indexed addressing mode. And what it does here is to replace a reference within the expression by a container dependent values. So the container which we use here is called myInst. This operator will extract the contents of this container and concatenate this to resolve the final string to access the variable on the PLC. I did that for all members of this struct, and finally when we select all and go to crossref, there is an easy way to display or hide this object by choosing hide and disable group. So I have another container which can be switched on or off by the calling control, which will hide and disable all the complete dialog. So we have a hide and disable if this open dialog container variable equals to 0. So this is our dialog in the foreground. Now, how do we call that? We will call that by adding a button, for instance. So this button can be transparent. I can place it on this object, and the action of this button will go like this. We will, on mouse down, we will write on the container my instance the name of the instance of this structure. So in this case it will be valve 1. For this object it would write valve 2, and on the mouse up condition we will write a 1 to this open dialog condition, which makes the dialog getting active. And when we remember this close button here, we'll write a 0 to the same container variable. Open dialog, it writes 0, which will close the dialog again and let it disappear. So this is how this indexed addressing works like. We can go again to see whether it works. Okay, so now we have 3 different objects. This one goes for valve 1 with these properties. This one will go for valve 2. I can modify the mode here and you will instantly see that it has an impact on this control. Here it will go for valve 1 again, and we can also change the error ID, for instance, and we see now we have error 2, error 3, etc.